As the world moves toward decarbonizing heating systems, seasonal underground heat storage has emerged as a potential solution for replacing gas heating in homes. This episode explores the feasibility of this technology, drawing on real-world examples, efficiency metrics, and cost analyses. By examining the evidence, we assess whether this innovation can become a standard feature of everyday life or remains a niche solution with limited reach. Can seasonal underground heat storage replace household gas heating as a viable, scalable, and cost-effective solution for domestic heating?
Time for a short conclusion. The benefit is that this is the first time in Finland that a seasonal thermal energy storage has been tested.
A groundbreaking project in Finland is set to change how we store and use thermal energy. In 2025, Finland announced the start of excavation work on Varanto, the world's largest seasonal thermal energy storage facility, located in Vantaa. The project, led by Vantaan Energia, will store 90 gigawatt-hours of thermal energy in underground caverns, enough to heat a medium-sized city for a year. If successful, the Varanto project could inspire similar thermal storage initiatives in other temperate regions. Communities in Europe may begin adopting smaller-scale versions of this technology, integrating it with renewable energy sources. This could lead to more resilient heating systems that reduce reliance on fossil fuels. While the Varanto project is a verified real-world development, its broader impact remains speculative and depends on factors like cost, efficiency, and climate conditions.
Do buy you some impressive RTEs. When I asked NES Store about theirs over email, a business development representative said that it had an RTE of 95%. Similarly, Andre Raimondo, the head of operations at Batsan,
could thermal batteries replace gas heating in homes? High efficiency suggests potential, but real-world performance is key. A study on an energy-efficient electric fireplace achieved a thermal efficiency of 24.64%, demonstrating the potential of electric heating systems in residential settings. However, this efficiency is lower than the speculative 95% figure mentioned in unverified claims. In a typical home, a thermal storage system could potentially store excess summer heat for use during winter, significantly reducing the need for gas heating. This could potentially lower energy bills and carbon emissions, making homes more sustainable. However, the high initial cost and long-term performance in varying conditions remain uncertain and require further research. The evidence does not confirm the existence of thermal batteries with such high round-trip efficiency, nor does it support claims about their use in homes. The cited study discusses an electric fireplace, not a thermal battery.
Compared to a regular heating system are high, and that's because it's a new technology. A lot of research was done at the same time, but it has shown that this is...
Despite its potential, seasonal thermal energy storage remains expensive and underutilized. Seasonal thermal energy storage, STES, stores heat or cold for extended periods, allowing it to be used when needed, such as heating in winter or cooling in summer. Implementation costs can be high due to factors like drilling and infrastructure, as noted in discussions about its adoption. The high upfront costs of STES may present challenges for adoption, especially in residential settings. The technology's affordability could improve with future innovations or policy support, but this remains hypothetical. For now, the cost barrier may limit its reach to a niche market. The evidence does not provide a direct comparison of STES costs to traditional heating systems, but it does confirm that implementation can be costly due to factors like drilling and infrastructure.
And push it all the way out to the perimeter by the end of winter, and then at the end of winter we're fully charged, at which time you'll see in the animation here we reverse the flow, and instead of the spheres...
Can underground heat storage systems be fully charged by winter's end, making them viable for home heating? Research has shown that seasonal underground thermal energy storage systems can be effectively charged by the end of winter, with studies demonstrating that increasing soil moisture content improves heat injection and extraction rates. A 2019 study found that burying heating pipes 2.5 meters underground enables seasonal heat storage, maintaining greenhouse temperatures above 8 degrees C, even in cold conditions. In the future, homes could use solar energy collected in summer to charge underground thermal storage systems, which are then used for heating during winter. This could reduce reliance on fossil fuels, but the energy required to push heat to the perimeter of the storage system might be significant. This might limit its widespread adoption, but ongoing research could help overcome these challenges. The practicality of seasonal underground heat storage for home heating depends on energy requirements for replenishment. Seasonal underground heat storage is a promising technology with demonstrated efficiency and functionality, but its current high costs and limited scalability present significant barriers to widespread adoption. While it may be a viable option for certain applications or regions, it is unlikely to replace household gas heating on a large scale without further innovation, cost reductions, and supportive policy frameworks. The future of this technology depends on overcoming these challenges and proving its value in the everyday lives of ordinary people.